Hello everyone. Today I will be explaining the electrolysis of brine. So the brine electrolysis of or electrolysis of brine. So basically, to do this experiment, we will need these following materials: glass of water, half of it, sharpen two pencils in both edges, a battery, and I recommend you to use the square one if you can, and table salt, and a piece of cardboard. So this is what the setup looks like. So the battery is attached to the pencil, and yeah, basically like this. So step one is you pour the table salt, to the glass of water. That's what I did right here. It's up to you to use how many uh, amount of salt, as long as it's enough for you. And then we have to attach the two pencils edges to the battery. So the one edge here of one pencil is attached to the battery in the negative side or positive side, and either way. So we must attach two of the pencil's edges to the battery, and make sure to sharpen these pencils so that um, we're using the pencil so that because the pencil inside of the pencil is made out of graphite, and graphite is made out of carbon, and we need that carbon to conduct electricity and to do this experiment. So step 3 is to make the two holes in the piece of cardboard as a holder for the pencils and the batteries, as I did before, like here. Step 4 is to attach the pencils to the holes of the cardboard here, like this, and place it in the mixed solution of salt and water in the glass. So this is why we need to sharpen both edge of the pencil, because one edge is to attach to the battery, and one edge is to attach to be put in the solution so that the electrolysis process will happen. So this is the video of what I do in the electrolysis process. So I put it in here, and as you can see, there are bubbles. So in the left pencil, as you can see, it is in the positive side of the battery, and the right one is in the negative side of the battery. And as you can see, the negative pencil, or the pencil in the negative side of the battery, is producing more bubbles than the left side, which is the positive side of the battery. I will explain it later. I will just give you the idea of it first. So basically, this is it. It will just continue to keep on producing bubbles. And so the results will be, as you can see, there are bubbles coming out of the pencils. And if we continue this to let this happen for a few hours, the solution will turn black and a possible poisonous smell will come out. So um, I didn't let it happen for like a few hours, because I will be wasting bat the energy of the battery. But I uh I can smell something weird which I never smelled before. And I think for what I know it's chlorine gas. So these are the elements in the electrolyte. So the electrolyte of this experiment is the salt water, which contains NaCl. NaCl is from the table salt, which is sodium chloride. So there is Na plus and Cl minus. And since the table salt is dissolved with water, the water contains H2O, which contains H plus and um, OH minus. So these are the gas products of the electrolysis of brine. We have hydrogen gas and chlorine gas. So um, chlorine gas is negatively charged, and uh, when a negatively charged ion, it is attracted to the positive side of the battery. In this case, it is attracted to the positive um, electrode. So the positive electrode is called um, the anode, and the negative electrode is called the cathode. So here, since chlorine is negative and hydrogen is positive, chlorine is attracted to the anode, which is the positive side, and hydrogen is, since it is positive, it is attracted to the negative side of the battery or the electrode, which is the cathode. So this is the products of the electrolysis of brine, which is hydrogen gas, as I said before, chlorine gas, and sodium hydroxide. So this is the chemical formula: 2NaCl, which is before aqueous, plus 2H2O, which is a liquid, and the result will be 2NaOH aqueous plus H2 hydrogen gas and plus Cl2 gas, which is chlorine gas. So what I said before, the weird smell that I'm smelling is chlorine gas. So be careful of this, but because if you breathe it too much, then it has the possibility of becoming poisonous. So explanation. As what I've said before, the negative ions is attracted to the positive electrode, and the positive ions is attracted to the negative electrode. And the negative electrode is the cathode, and the positive electrode is the anode. So basically, as I was saying before, uh, chlorine is negative and it is attracted to the um, anode. And since chlorine is a diatomic molecule, it has to pair up with another molecule. So basically, in the anode, it's where the oxidation process happens. So what is oxidation? It is the reduce of electrons. It's the loss of electrons. So since the negative ions of chlorine is attracted to the positive electrode, it absorbs the electrons from the chlorine. And so since the chlorine is negatively charged, it is um, it is becoming neutral. And so since it has to pair up with other, it will become a gas and it will float up. And so you can see visually it becomes gas. And for the other one, hydrogen, since hydrogen is positive and it is attracted to the negative electrode, which is the cathode. So the um, cathode is where the reduction process happens. So when the um, reduction is basically the gain of electrons. So the hydrogen is gaining electrons. So the hydrogen, since it gains electrons, so it becomes neutral. And since hydrogen is also a diatomic molecule, it has to pair up with another hydrogen um, atom. So it then, after it pairs up, since it is neutral, it goes back to its state of matter, which is gas. So when it is gas, it floats up, and as you can see, um, it forms bubbles. So why does the um, chlorine gas, or one side of the um, pencil is producing more bubbles than the other side? So basically, it is since um, the negative side is has the reduction process happen, and so the hydrogen is attracted to it. It produces more uh, bubbles because um, it basically gains electrons. That's why. And then for the other one, for the uh, hydrogen oxide, since it is OH minus, it is negatively charged. So it is attracted to the anode, which is the positive side, and it basically the same. It um, loses its electrons and become neutral, and it goes back to the its original state of matter, which is liquid. So that's why the um, hydrogen oxide is aqueous, because that is the original state of form, state of matter of it. And for the sodium, since it is positive, it is attracted to the cathode, which is the negative side, the negative electrode. So in the cathode, it's the gain of electrons, and when the sodium gains electrons, it becomes neutral, and sodium goes back to its state of matter, which is solid metal. But then, wait, since sodium is inside the solution, which is um, the hydrogen oxide, which is aqueous, so they mix together and they form sodium hydroxide. So this products of electrolysis is very useful for our lives, since yeah, basically that's it. That explains what electrolysis of brine. So thank you for your time and attention, and I will see you next time. Bye.